Hello guys, my name is Sandeep and today we are going to start the second session of your force chapter, right? Okay. In the previous session, if you do remember, we have learned what are the different forces. What is force actually? It is nothing but pull and push, we can say, right? We have taken that example, if you do remember specifically, that car is, you are pushing the car, your brother and you are pushing the car. Then also pull is also the force, right? We also have studied a lot of different types of the forces, that is gravitational force, then we have the nuclear force. What are the other forces? I told you there are total 4 forces, right? First one is gravitational, second one is, let's say, electromagnetic force, third one is strong nuclear force, fourth one is weak nuclear force, right? So we can say there are 4 different types of forces, right? We have seen these things. Then we also segregated the forces according to contact forces, non-contact forces. If you do remember, we talked about tension, normal, friction, etc. Then non-contact forces like gravitational force, electrostatic force, those are our non-contact, right? Then we also talked about the equilibrium, then first law of Newton's laws of motion. So I hope that everybody now remembers all those things. So now we are going to move our second section of this force and pressure chapter. Okay, sure. So let's start. So first of all, let's see what we are going to study. Right, as I said, Newton is going to be there for with us for up to 11th and 12th, right? So this science is really important for us. And so today what we are going to study: normal reaction, tension, free body diagram. If you do remember, we already talked a lot about the normal and tension. You also know, right? Now today we are going to solve some questions. So we are going to study in detail what are the normal forces, what are the tension, and the free body diagram also explained about something about this one, right? Free body diagram means draw how many forces are acting on that object or body. This is called as free body diagram. Okay. Then now when we say normal reaction or normal force, do anybody remember what is normal force? I drawn the diagram something like this. If you do remember, and I call this as the normal force. Okay. So let's see what's normal force. Now consider a very simple example. Consider you're standing on a ground. Now you are standing on a ground. Tell me which force is acting on you. We already know that Earth's gravitational field is attracting you, right? That's very good, right? So Earth is acting force on you. Earth is attracting, we can say. So Earth's attraction is towards the center. Then tell me one thing: who is stopping you to go toward the center of the Earth? Who is stopping you? Floor? Can I say floor? That's right. Floor is stopping us from going towards the center of the Earth. Then now think on that. Earth and floor, right? Earth and floor, do they have any comparison with their forces? Can floor stop you from going towards the Earth? No. Then how we are saying that floor is stopping the Earth from attracting you toward the center, right? So remember what we can see here. Consider if you are standing on the ground like this. Okay. Now, whatever is the force which Earth is attracting, with which Earth is attracting you, we call this as Emg force. Right. Now consider, let's assume your mass is, let's say, 50 kg. Yes, let's take 50 kg mass. Acceleration due to gravity is 9.8. That's good. So if I do this calculations, I'll get something like this: 490. 490 Newton is force. Right? So Earth is attracting you only with this amount of force. It completely depends on only this G part and whatever is the mass. Right? So as your mass is very less, 490 is not that big a force. So obviously Earth can provide that much of opposite force which it is providing, like this, on you. Therefore, we can say those are equal and opposite force. Though Earth can provide lot of force, right, which depends on obviously the mass of the body. If you consider the mass of, consider a very big object, right? Plane or aeroplane, we can say, right? That mass will be very high, right? So what we can say, Earth will attract it with that much of force, but still the ground on which it is standing can apply the opposite force, which is going to equalize those two forces, right? So this ground or floor, we are going to call this as a normal. Very simple concept, right? And we also know that normal. What it is doing, it is actually providing the neutralizing force, we can say, right? Which obviously will stop you to go towards the earth. Okay, so we can say this is our normal force now. Now let's talk more about this normal force. So this is our basic diagram, right? On any table, consider any block is kept like this. Just okay. As we already know, Earth is doing what? Attracting that block towards where? Towards its center. Who is stopping it? The table is stopping in this case, table is stopping it, right? So table is applying the force N, which should be equal to how much? Which should be equal to Mg. Mg is what? Mg is the force applied by the earth on the object, or we can say this is nothing but the weight of the object, right? So there are two forces acting on that block, that is Mg and normal. Normal is applied by table. Mg is applied by earth. Simple. Now, consider if I put a very bigger, heavy object here. Consider capital Mg, right? On this table, what will happen? Table is also going to apply the same force, we know that, right? En, let's call this as n1, let's call this as en2, right? So table is applying the normal force to both the objects, right? Now what happens if this force is very high, this mass is very high? What will happen? Simple, table will broke down, right? So there is obviously a limit for how much force, how much normal force, we can say, this table can apply on that block, right? If this mg, total mg, whatever is the mg, is exceeds that normal force, obviously it is not going to be in equilibrium. We have talked about the equilibrium, right? If one of the force is greater, this whole object will come down, and obviously in this case table will break, right? Okay, so now, so this is our normal force. Now one more concept, very important, you are supposed to remember about this normal force is, first of all, it's a contact force. I can say it's a contact force, right? We know that, we have already seen this in the previous session. Then remember, this is the type of electromagnetic force. So I can say this is electromagnetic force. Simple. Then what else you should remember? The very important concept which we are going to use throughout the 12th and your entrance exams. That, remember, third point is very important. This force acts perpendicular. This force acts perpendicular to the surface. Now let's see what is the meaning of this. So these are the 3 points which are very important for us, right? So third point, as I was saying, very important point, this force acts perpendicular to the surface means what? Let's see. Now for this table, we can consider this table, right? Let's forget about the second block, concentrate on the first block only. I know there are Mg forces there, and table is applying the force which is equal to normal force, right? We also call it normal. Why normal? Normal means perpendicular. So in this third point, you can see why we are calling this force as a normal point or a normal force, right? So what I was saying, the table was applying the force perpendicular to the surface. Surface means what in this case? Obviously table. So if you can see, this is the surface, and tell me how much is this angle? right? This angle obviously should be, I can say it is 90 degree, right? So let's say this is 90 degree. So normal force always acts perpendicular to surface. Mg, we also have studied about the mg. Mg means what? Gravitational force. Gravitational force, remember, always acts downward, right? Okay. Now let's take one simple example on this. Now consider this is the inclined plane. We can see the inclined planes, right? Okay. We can say this is slide, right? Slides for children on the garden, right? So those slides are inclined plane. Now consider if any child is on that, or just consider now a block is kept there, right? Let's see how many forces are acting on this. Mg, remember, Mg should always look like this, that is downward Mg. Okay, and our normal, again, normal is perpendicular to the surface. So who is our surface now? This is our surface. So let's draw one force perpendicular to this one. Perpendicular means this angle should be 90 degree, right? We know this point. So now you can see here, normal is not necessarily always upward. On horizontal table, we can see normal is acting upward, exactly upward, right? Here you can see normal is inclined to the slide through 90 degree, right? Simple. Then consider one more case. Now this is the wall, right? We have our walls in our rooms also, right? This is our horizontal wall. This is which can call this is our floor, right? So floor is horizontal, wall is vertical. Now consider if I'm keeping one object like this, right? First of all, tell me whether this object will remain there. If you just keep one object like on the wall, right? Will it stay there? Obviously not, right? Why it is not staying there? Because we know mg is acting downward. So this mg force means this Earth's gravitational attraction is going to bring that object downward up to which level? Up to ground, we can say, right? Now consider I am holding this object like this. I'm holding like this object with my palm. What will happen? Obviously, it will stay there now, right? So, what we can say, I am applying some external force. I'm applying some external force. And what about normal in this case, right? Now, just let's not worry about this applied force. We will assume that applied force is there, and let's talk about the normal. Now normal, as said, again very important, normal is perpendicular to the surface. So what I'm supposed to do, draw one diagram which is perpendicular to this, right? And let's call this force as normal. You can see again the surface and this angle is 90 degree, right? So this is our condition that the normal should be perpendicular, that is 90 degree to the surface. Okay. So what we have learned about the normal, first of all, 3 points are very important. First, it is a contact force, right? Means obviously there should be contact between two objects, and then it is electromagnetic force. And the most important thing is this force acts perpendicular to the surface. Now, give me one example, one answer, quick answer to this question. Consider this is table, and one block is kept on the table like this, right? We already know now that force is acting upward and mg is acting downward. We already learned about the equilibrium. This is 90 degree, right? Is any other forces acting on that? Yes, anybody can guess, right? So I can say only two forces are acting on that. There is no other force there, right? Now tell me whether this block is in equilibrium or not. Simple. We can say mg, as long as mg and n are equal, then we can say that body is in equilibrium, right? We can again consider our example of laptop in front of you or mobile in front of you, right? It is at equilibrium, right? It is at rest, right? Now, what I'm going to do, I'm going to pull this block upward with external force. Now let's see what happens. Right, this diagram will become something like this if this is stable. And now as I'm pulling this, right, and let's just we can carry our laptop or mobile, right? What will happen? There is no contact between table and our laptop or this block. In this case, we can say, tell me, is there a normal force in this? First force is mg, that is right. Is there a normal force? No, obviously not. There is no contact between the table and the block. Obviously, there will be no normal. So who is pulling this upward? Obviously, external force. We have already applied the external force. So now F and mg will balance each other. Then we can say that obviously it is in equilibrium as long as you keep pulling that laptop upward or pulling that block upward, we can say, right? So this is the normal reaction and external force mg. These are the different diagrams we can see.